Hello learners, welcome to our virtual learning class. Today we have integrated science and we are still under what? Simple machines. Okay, simple machines. Good. In our previous lesson, we learned of what? Simple machines. And we learned that a machine is what? Any tool that helps us to work easier and faster. Okay? We learned that a machine is any tool that helps us to work easier and faster. I also learned that simple machines are machines that are made or can be made easily. Okay, very good. But today we are going to talk about what? Levers, okay, or a lever. Good. Before we continue, let's look at the objectives for today's lesson. At the end of the lesson, we should be able to explain what a lever is. Okay. At the end of the lesson, we should be able to explain what a lever is. Good. If you are ready, let's continue. So a lever is any rigid bar which rotates at a certain fixed point called fulcrum, called pivot or fulcrum. Okay, very good. Any rigid bar which rotates at a fixed point called fulcrum or pivot. Okay, for example, let's look at this. Okay, let's look at this. You see, you can see that this is a bar. It's rotating at the center here. Okay, it's rotating at the center here. So it's an example of what? A lever. We say it's any bar which has a fixed point that it rotates. Okay, you can see. You can see. Okay, the same way when we look at example our seesaw in our school and in our churches, you see that it rotates at what? A fixed point. Okay, so seesaw is also an example of a lever. When we look at our scissors, okay, this is the same as what? A scissor or a pair of scissors. Okay, it's the same as a pair of scissors. It's also rotate at a fixed point. Okay, so we say what? A lever is any rigid bar which rotates at a fixed point called a pivot or fulcrum. Okay, good. Now let's look at some examples. We have bottle opener. Okay, it's an example of a lever. We have scissors. We can see that the center of the scissor it can rotate. Then we have barrel. We have wheelbarrow. We have crowbar and shears. Okay, very good. These are some examples of what? A lever. Okay, we have bottle opener, scissors, wheelbarrow, crowbar, and shears. When we look at the scissors, when we look at a pair of scissors, we can see that the center, it rotates at the center. The same way when we look at the wheelbarrow, see that the tire, it has a fixed point that it rotates. Okay, very good. The same as the shears I've shown to you. Okay, good. Now let's look at part of what? A lever. So actually a lever has three main parts. Okay, the first one is effort, and when we talk of the effort, is the force applied. Okay, good. Let's look at this. This is what? A crowbar. Okay, very good. When I want to pull a nail from this table, okay, I hold here, I hold the nail with this place, then I apply the force. Okay, I push this place or I pull this place. Okay, so this place is where I've applied the force. So this place is what? The effort. Okay, very good. Now the nail here is the load. Okay, because the nail here is the work that I'm doing, so it's the load. Now when we look at this here, where it touches the table, okay, it moves. Okay, it moves. So that place becomes what? The pivot. Okay, let's look at this. This is a chair. We say it's an example of what? A lever. I would say a lever is having what? Three main parts. Okay, you have the effort. So when I want to use this to work, this is where I'm going to apply the handle. This is where I'm going to apply the force. Okay, so that place becomes the effort. Now the center here where it is turning, okay, the center here becomes what? The pivot or the fulcrum. Okay, good. And the leaves that I'm cutting with it become the load. Okay, the work I'm doing with it becomes the load. Very good. Let's continue. So we have the effort. I would say the place where the force is what? Applied. Okay? The force is the place where the force is applied. For example, when you are pushing a wheel or pulling a wheelbarrow, the handle where you hold before pushing, okay, is the effort, because you apply the force over there before the wheelbarrow starts moving. Very good. So that is the effort. Then the load. The load is what? The weight the machine is what? Lifting, or the work is doing. Okay. So when you place a block in a wheelbarrow, okay, when you place a block in a wheelbarrow, okay, now the block become what? The load. Okay, the block become what? The load. So it is the weight that the wheelbarrow will do what? Will carry. So the block becomes the load. Then the pivot, the part where it turns, or which rotates, become what? The pivot. Okay, where it rotates is the pivot. Okay, the fixed point about which one the lever rotates is the pivot. So we are taking this one again as example. You see the fixed point. You see that it rotates here. This is the fixed point. It do what? Rotate. You see. So this place become what? The pivot or the fulcrum. The same way when we take this one too. You see that it rotates here at the center here. So it become the pivot. Okay. Very good. Now let's continue. So we are saying that we have three main parts of what? A lever. We have the effort, where the force is applied. Then we have the load, that is the weight it's carried, or the work that is being done. Then we have the pivot, where it rotates. Okay, where it rotates. Very good. Now let's look at this drawing here. We can see that this is something like, it's just something like this. Okay, it is just something like this. Okay, then and we place, this is the load. Okay, when we, or a seesaw, you see, when I leave it, it's going down because it's having what? Weight. Now when I push it, it's coming up. So this place becomes the pivot. This is where it is turning. Okay, it can turn. It can turn. Okay, this is where it is turning. So this is the pivot, and where I am applying the force. Okay, or where I hold before turning it is what? The effort. Okay, is the effort. So when we come here, we can see that this is the load. This is the load. This is the pivot. Where it turns. And where the force is applied is the what? The effort. So looking at the arrow, you can see that the arrow is telling us that force is being applied over there. Okay, very good. Now let's continue with classes of levers. Classes of lever. We talk about parts of lever. We say we have three main parts of our lever. That is the pivot, the effort, and the load. So let's look at the classes of levers. Now we have first class of lever. Okay, I would say the first class lever, the pivot is between the effort and the load. The pivot is between the effort and the load. Okay, and we are saying that the pivot is the point at which the turning occurs. So when we look at this here is an example of what? First class lever. Why? Because this is the pivot. Okay, it is between the effort, where the handle, where I apply the force, and the load, where it will work. Okay, so the pivot is between the load and the effort. So it's an example of first class lever. And another example of the scissor, a pair of scissors. Okay, the scissors. Okay, the pair of scissors we use at home for cutting our cloth or papers. Okay, it's also an example of first class lever. Why? Because when you look at it, you see that the part that I used to cut the paper is at the other side, and where you hold before cutting, and where it turns is at the center. Okay, for example, like this. Okay, you see that it rotates here. The scissors to a pair of scissors to is the same thing. It rotates here. Okay, so it's first class lever. Let's look at some example. We have a pair of scissors. We have pliers and shears. Okay, this is a shears, and then we have a pair of scissors. Then we also have pliers. we all have what? The pivot at the center. Like example, this is the pivot, this one at the center. This is the load, this is the pivot, and this one the effort. So you can see that the drawing here is about the first class of lever, okay? Because this is where it will turn, and the load is there, and this is where we apply the force, okay? Very good. Let's continue with the second class of lever. So the load is between the effort and the pivot. Okay, the load is between the effort and the pivot. A typical example is the wheelbarrow. Okay, the wheelbarrow. When you look at the wheelbarrow, see that the car is in front. Then where you carry the load, okay, the bucket is in the middle, and where you handle it, or where you hold the handle, where you hold is also at the other end. So when you look at it, you see that the load, the pivot, the wheelbarrow, the tire is here. The load, the basket is like this here. Okay. Then this is the handle where you apply the force before pushing the wheelbarrow. So you can see that this one is what? A second class. You say that the load is between the pivot and the effort. That is for what? Second class lever. Okay. The load, wheelbarrow is a typical example. Okay. Then we also have what? Nutcracker and what? Crawl bar. Okay. We have crawl bar. Very good. Let's look at the last class of lever, which is what? The third class of lever. Also, the third class of lever is what? The effort is between the load and the pivot. Okay? The effort is between the load and the pivot. Very good. Typical example of stapler. You can see that the stapler, when you want to use it, you hold the middle before pressing it. Okay? You hold the middle before pressing it, before the pin will be able to go the paper we are stapling. Okay? So it's an example. When you hold, you see that the effort is between the load and the pivot. Okay? You have to press the middle before to hold. At the same time, the fire tongue is just like this, something like this. Okay, the fire tongue is something like this. Okay, so you hold this place, you apply the force there, then this place is the load, that's something that you are carrying. Okay, before this one will hold it, then this is where it will move, the movement will take place. Okay, so the load is the effort is between the load and the pivot. Very good. Right, if you are clear with this, then let's continue with the maintenance of simple machines. How we can keep simple machines to be there for a longer period of time. What we can do to them to keep them to be there for a longer period of time. Number one is saying we should do clean tools after using them. Always after you finish using them, you have to do what? Clean them. Okay? When we clean them, they are always neat and even sharp for us to be used. Very good. And then number two is we have to store them in a cool, dry place. Okay, we are not supposed to expose them to the moisture or to water. Okay, because most of our simple machines are made of metals. Okay, they have metal parts. So when it's exposed to water, the metal part will rust. Okay, it will rust, and gradually we are losing our machine. Sorry. Good. Now the number three is use the simple machine for the correct purpose. Okay. Now this shade here is for cutting hedges. Okay, it's to cut hedge. But when we are using this thing to cut metal, you see that the mouth will become blunt, and we will send it to be sharpened. And when we are doing that, we are reducing its efficiency or how it will work. Okay, we are reducing its size, and to cut the tie to become very small. Okay, so we have to use the tool for its purpose, the work it has been designed for. Then the last one is we have to oil the metal part of the tool to prevent it from rusting. For example, when we have this is we have from here up to here is metal. Okay, this side is rubber, the handle is rubber or plastic, but this side is metal. So after you finish using them, you have to clean them After cleaning, then we oil the metal parts. Okay, we oil the metal part. Then this will prevent them from what? From rusting. Very good. It will prevent them from what? Rusting, because water cannot pass through the oil to get into contact with this. So because before rusting happens, there must be contact with what? Water. The metal has to be in contact with water before the rusting takes place. So when the oil is there, the oil will prevent water from getting into contact with what? The metal, and that will prevent what? Rusting. Okay, very good. I hope you are getting it. So this is how we have to maintain our tools or our simple machines at home, so that they will be there and they will last long for us to use always. Okay, so I would like to bring the lesson for today to an end, and until we meet again, have a nice day. Bye.